What's up, everybody? Welcome to Colorful Analysis channel. I'm so happy you are here. In this video, we are going to dive into different type of algorithms from the old to the latest. It's like unwrapping a colorful gift of knowledge about how machine learns and make a decision. Get ready for a fun and easy to understand journey in the world of the algorithm. Let's jump in. First one, supervised learning. Think of supervised learning as having a teaching assistant for your computer. You provide these digital assistants with a lots of example, just like a teacher gives example to a student. In each example, you not only show a problem but also share the correct answer, much like providing the solution to a math problem. Supervised learning broadly encompasses two main types: classification and regression. Classification: the goal is to assign input to predefined categories or classes. The algorithm learns from labeled training data and then classifies new, unseen instances into one of the learned categories. Support vector machine for email spam detection and decision tree for predicting whether a student pass or fail in exam would be in this category. Regression. In regression, the algorithm predict a continuous outcome or numerical value. The goal is learn the relationship between input and output to make prediction on a new unseen data. Linear regression for predicting house price based on features. Random forest for estimating the sales price of the product would be in this category. Let's dive into unsupervised learning. It's like letting the algorithm explore data without a specific instructions. It's discover patterns or group, means that clustering, or simplifies complex data by reducing its dimensions without using predefined label. It's called dimensionality reductions. Commons clustering is like organizing items into groups based on their similarities. It iteratively assigns data points to clusters, aiming to create groups where points within a cluster are more similar to each other than those in other clusters. For example, retail store categorizing customers based on their purchasing behavior. Commies help identify distinct group, allowing for targeted marketing strategy for each cluster. Dimensionality reduction algorithm, principal component analysis or PCA, is like simplifying a complex problem by focusing on the most important aspects. It transforms high dimensional data into a lower dimensional representation while retaining the essential information. For example, imagine you have a detailed image and you want to recognize object in it. PCA can help reduce the number of features while preserving the critical information needed for accurate object recognition, making the process more efficient. Another category of algorithms called reinforcement learning is about finding the best strategy for the agent to maximize cumulative reward over time. It's a dynamic process of learning from experience and adopting behavior to achieve desired outcome, much like teaching a pet to perform tasks for rewarding. Imagine teaching a dog new trick. When the dog performs a trick correctly, you reward it with a treat. Over time, the dog learns to associate a specific action with the rewards and adjust its behavior to receive more treats. I would like to add key concepts of reinforcement learning: agent, the learner or decision maker, like a dog in the analogy; environment, the external system with which the agent interacts, the surrounding where the dog learns tricks; action, the decision or move made by the agent, that is like a trick performed by the dog; and the reward, the feedback give to the agent after taking an action, is like the treat for the dog if the trick is well done. And the goal, the objective the agent aims to achieve, teaching the dog to perform tricks for treats. Real world application of reinforcement learning. Think about that training a virtual character game. The agent explore the game environment, take action, and receive reward or penalty based on its decisions. Through trial and error, the agent learn to navigate the game world effectively. Do you know that reinforcement learning has a two-type algorithm, model-free and model-based? One of them is Q-learning. Q-learning is like teaching a computer to find the best way through the maze. The computer learns by trying different paths and getting feedback or reward on its choice. Over time, it figures out the most efficient route to reach the destination. If you want to know about one of the application would be uh, imagine a robot navigating through a maze. Q learning helps the robot learn which action, turn left, turn right, to take at each junction by associating positive reward with the good choices and negative rewards with the bad ones. The next one, model-based algorithms. One of the algorithms in this category is model predictive control, or MPC. MPC is like driving a car using a GPS that predicts the road ahead. It plans the best route by considering the current state, means that location, predicting future states, and adjusting the path in real time to reach the destination efficiency. Think of an autonomous car on a busy road. MPC help the car continuously predict and adjust its path, considering the position of the other vehicles and obstacles, to drive safely and reach its destination smoothly. Deep learning is like training a computer brain with the many layers to understand and interpret complex patterns. It uses artificial neural networks inspired by the human brain to learn from vast amount of data and make intelligent decisions. Key concept of deep learning is neural networks, layers of interconnected nodes, neurons that mimic the human brain's structure. Deep learning involve many layers, allowing the model to learn intricate features and representations. Training: the model adjusts its internal parameters using labeled data, aiming to make accurate predictions. Thanks for diving into the world of algorithms in simplest way. Stay tuned for future video. See you next time.